Oh, I already made up all my jokes. Oh, I told you the one about the really ugly new Apple phone, which is, I didn't tell you about the new ugly phone. It's called the eyesore. All right. So, in any case, that's the joke of the day. So, using fundamental identities. Okay. Using fundamental identities, this is what this section is entitled, and the reason I gave you that sheet is because you're going to use these to simplify things and stuff like that. So, so I don't like this color, so I'm going to change colors. So use fun identities, fundamental idents to find. This is bad writing. To find all 6 trig functions if secant of u is equal to negative 3/2 and tan of u is greater than 0. Okay? And so this is a little bit different than if you do this by, it's just another way to do what we did in the last chapter. But in the last chapter, we were drawing the triangles and doing all those things this way. In this case, we're going to use the identities instead. Okay? And so, would you want to do it this way, or would you want to use the triangle? I think the triangle method is quicker and easier, but this is kind of getting you ready to solve trig equations and things like that. So secant of u is negative 3/2 and tangent of u is greater than 0. Your first step in doing this, Miley's, is to figure out what, Miley's?
The trig functions.
Yeah, but that's not the first step. First step you want to do, what does this tell you? What does this info right here tell you?
Where the triangle is.
It says which quadrant you're talking about, right? So secant is negative, and secant and what are related to each other? Cosine, okay? So this is like, where is cosine negative and tangent positive? So what I would do, where's cosine negative? Here and here, right? Where is tangent positive? 3rd and 1, right? So where am I if I'm talking about this? I'm in the 3rd quadrant, right? So the first thing you really need to decide is which quadrant you're in, okay? Otherwise, you're going to get all the wrong answers, like some of you did in that first quiz. You had all the negatives where you should have had them positives and stuff like that. So you have to figure it. So first I know that I'm in the 3rd quadrant, so I know everything is negative except for tangent and cotangent are going to be positive. So rather than draw the triangle, I know you guys could draw the triangle and figure out that way. But we're going to do this using the identity. First thing I could do is find cosine, because I know that secant and cosine are related, because they're reciprocal. So what's a cosine of u?
-2.
-2/3. I don't even have to do anything. I don't have to look at the triangle or anything. I just know because cosine and secant are reciprocal identities, I could just flip that over and get secant. Okay? The next thing I'm going to do, since I know sine, you wouldn't normally want to do this, or maybe you would. And I saw some people doing this on the test, where they shouldn't have been doing this, but it's okay. Cosine u equals 1. I'm going to use this to find sine, okay? Because they're always related by this trigonometric identity, so I can plug in -2/3 in for u, and so sine squared u plus cosine of u is -2/3, so that means I can take -2/3 and plug it in there and square it, and that's equal to 1. See what I did? Okay? What's negative 2/3 squared?
Negative 4
Not negative,
4 nines.
positive 4 ninths. All right, you have to square the top and square the bottom. Now what do I do? Subtract 4 ninths from both sides. Minus 4 ninths. Minus 4 ninths. And I get sine squared u equals 5 ninths. Now what? Square root it. So sine is equal to plus or minus the square root of 5 ninths. So I'm in the third quadrant. Is sine negative or positive there? Negative, right? Why is negative there? So sine of u is the square root of, this can be written as negative square root of 5. I can pull a 9 out from the bottom, which is 3. Oh, don't ever do what I just did. Don't just leave it as sine. You have to leave it as sine of u. Okay, you can't just, don't just, I saw some of you doing that. I didn't take off on a test. If you did, I know it's a pain to write the u every time and all that. But it's kind of like saying square roots. You know, it's just an operator. Sine is just a, it's not, sine by itself doesn't mean anything. So sine of u equals, so now I have, what do I have? I have sine, I have cosine, what else do I have? I have secant. I can get cosecant now, because what's the relation between sine and cosecant? They're reciprocal, so I could just flip this over and find cosecant. I just leave the negative up top. And you could rationalize that if you want. I'm not going to take off if you don't rationalize it. Okay? You should know how to rationalize them. And now using another identity, tangent of u is equal to what? What over what? Sine over cosine on that sheet, right? And I have sine, which is negative 5 over, negative root of 5. That's a root of 5 in case you can't read it. Root of 5 over 3. And cosine is, right there, negative 2 over 3. Do you guys know you could cancel out those 3's? If you don't remember that, do the copy dot flip thing, which I learned from my algebra students. Have you heard that before? Copy dot flip? Okay. Copy dot flip means you copy dot flip. So you copy the top, negative root of 5, 3, you dot, and then you flip this, okay? Negative 2. And then see what happens? The 3's go away, the negatives turn into pluses, and you're left with tangent of u is root of 5 over 2. No, because the negative divided by negative makes positive. Okay? And so I have everything except cotangent. How do I find cotangent? Flip it over to over root of 5. Right? Or 2 root 5 over 5 is better. But if you write it like that, I'm not going to be wrong. Okay? I want to keep it simple.
Why
Yes?
would you just use a triangle?
Because it's another way, and you're kind of setting it up for solving equations. It's using the identities, right? Yeah, it would be much quicker to use a triangle. I agree. But you know, the other thing is, sometimes when you just have fractions, Delaney, it's hard to figure out how to set up the triangle and stuff like that. Okay? So that's using trig identities to find the other trig functions. Now we're gonna do some other stuff. Simplify. These are fun. I love these ones. Simplify. And they get a little harder as you go. Simplify sine of x, cosine squared of x. This is the first one. This is the first one. Cosine squared of x minus sine of x. If you have trouble thinking when there's sines and cosines and stuff, change everything into x's and y's sometimes. Like so what I told the last class, I could think of this as, I don't know if this will help, but I could think of it as xy squared minus x. I could think about that way. I don't know if it's that helpful in this case, but what is in both of these? Sine of x, right? So what can I do if there's a sine of x in both of those? I can't just cancel out. I can factor them out, okay? So I'm going to pull out a sine of x, and this is a strategy you use when you're solving equations. Cosine x minus what?
1.
1. Do you guys see where that comes from? You're factoring, just like you would factor in an algebra problem. I'm pulling out a sine of x with both of these. So that's sine of x times cosine squared x minus 1. But cosine x squared minus 1, when it says simplify, you want to get it like as condensed as you can. Okay? And I have this identity that says sine squared x plus cosine squared x equals 1. So how could I do something like use this formula to find something over to do a substitution? What could I do? Yes, that?
I think you could substitute the entire thing with negative sine squared x.
Very nice. Okay, because so he kind of jumped ahead a little bit. That you could do it. That's a good way. But what he saw is he said, okay, I see sine squared plus cosine squared x equals 1. I can bring the sine over here and the cosine over there, and say that cosine squared x, just look at this and say, oh, cosine squared x minus 1, that would be equal to negative sine squared x, right? Or what I tend to do more, I know that cosine squared x, well, I think that's what I would do. Cosine squared x minus 1 is equal to negative sine squared x, right? We did it differently in the other class, right?
So you would take
And
one.
yeah, I bring the 1 over here, I brought the sine over there. And now I can go sine x times negative sine x squared, right? And what does that simplify to? What's x times negative x squared? What's x times negative x squared? Negative x cubed. So sine of x times negative sine squared is negative sine cubed x. And that's about as simple as it can get. Okay? Yes, sir?
What happened to the square root on the sine on the top right?
The square root on the sine.
No, I mean the squared. Sine
This?
squared. Yeah.
It's right here, right? Because if I bring cosine squared x minus 1, right? If I bring this onto this side, right? Is equal to this, right? If I bring that on that side. And then I substituted in here, right? I took this
Oh, I get it.
and I plugged this into here, right? Yes? Got it? You get that? Not too horrible? Yes? But all these are a little bit different, so it's kind of... You don't understand how I substituted?
No, I understand the substitution. I don't understand why the signs went away.
Oh, because it's like,
Where? Here? Down here?
it's
That they didn't go away. I was just trying to give you an analogous algebra problem. Okay, maybe they. Yeah, you can't just take the signs away. Yeah. Okay. Mike, you can't do this, right? Sine x over tan x or cosine x. Oh, you can't do that anyway. What was it? What was that thing? I forget. Oh, they had a picture of Bill Cosby, and they simplified like sine over tangent or something, and it turns into cosine. Sine of b over cosine b is Bill Cosby. Okay, I don't know. There's all kinds of weird ones, good ones like that. Okay, not weird, but good. Okay, so what if they say factor? Secant squared x minus 1. What would you do if you saw, let's change it to a theta, okay? Secant squared theta minus 1, okay? You could use an identity, but I don't think that's really going to help. Well, yeah, but it's just tangent squared, but you're not factoring, right? So you don't want to do a substitution here. What you want to do is you want to actually factor this. So this is like saying, instead of saying x, I'll say y squared minus 1. What is y squared minus 1 equal to? How does that factor? Negative 1 and
1.
plus 1. This factors use y plus 1 times y minus 1. Do you remember that from algebra? That's called the difference of two squares. Okay? You should have learned that in algebra, but if I unfoil this, right, there's no middle term, which means these things had canceled each other out. So y squared minus 1 factors to that. That means that secant squared theta minus 1 would factor to what?
Secant squared theta
Sec-
minus 1 for
Not secant squared theta, secant theta plus 1 times secant theta minus 1. Why would I ever want to do that? Because if you're solving a trig equation that involves secant squared theta minus 1, you would set it equal to 0, and you would solve each pieces of those individually, which we'll do in section 5-4. Okay? So that's simplified. No, because this one said factor. It didn't say simplify. It said factor. If it said simplify, yes, I'd probably just change that into tangent squared theta. Okay? But if it said factor, that's what they want you to do. Okay? And that's a method for solving trig equations. What if they say factor this? And you say, you make up a bad answer. What if they say factor this? 4 tan squared theta plus tan theta minus 3. And they say factor that. This is the same as if you were factoring what? 4x squared plus x minus 3. If it helps you to write it out that way, write it out that way.
So
Okay?
theta can be considered x.
No, the whole tan of theta can be
Okay.
thought of as x, right? Or cosine of theta. Okay? So now it's 4x squared minus x, and this factors to, I'll just tell you, because I know that you guys learn factoring different ways, but I happen to know that 4x goes here and x goes there. You can break it into 2x and 2x, but you have to try all the combos, or you could use the cross and box method or the Indian method. There's all different ways, you know. But however you know how to factor, hopefully the factoring won't get so complicated that it becomes an algebra problem rather than a trig problem, right? Because that's what we want. So what number goes here? Who knows what goes here?
Negative.
1. 1? No, I think the 1 goes there and the 3 goes here, doesn't it?
Yeah.
Because that's got to be plus and that's got to be minus, right? Yes? Minus 3x plus 4x. Okay? Yes? So this factors to, that's right, believe me. So this factors to 4 tan theta minus 3 times tan of theta plus 1. That's what they mean by factoring. Just like that. So if it helps you to do this problem and then rewrite it like this, it's okay. Okay? But it's the same. That's really what you're doing, is doing an algebra. Questions? Okay.
So that would be the answer.
So that would be the end. Yeah, if they just had factored now in chapter, like I said, when we get to 5-4, you'll be solving equations where you set it equal to 0, and then you have to find out where tan theta minus 3 equals 0 and tan of theta is equal to negative 1. So, but we're not doing that quite yet. Hey, no laughing, girls. We got to practice for when the is here. Okay. So what if they said, do this, cosecant, and they say factor? I'm going to get a new page. Factor. And they say cotangent of x. No, they don't. Yeah, cotangent squared of x. No, they don't say that either.
Oh my god.
Sorry. I'm looking at my notes, but I'm looking in the wrong place. Cosecant squared of x minus cotangent of x minus 3. And they say factor. And you say, I can't factor there because I got like apples and oranges over here. Can I change them all into apples? How can I change cosecant squareds into apples for a cotangent? I don't. I could do sines and cosines, but that's going to give me fractions, and you guys don't like fractions that much, right? Or not? And so I want to change this to look like this. Okay? How could I change cosecant squareds into cotangent? Look at your sheet. Okay? Cosecant squared is equal to 1 plus cotangent squared x, right? Minus cotangent x minus 3. Now, before I can factor, I got to get these things together, right? So I have cotangent squared x minus cotangent of x minus what? 2. And now I can factor it because I have all apples, right? Or all y's or all x's or whatever you want to call it. So how does this factor, Delaney?
You could do
What does?
-1 or
Yes?
-1 and +2.
I think you got it
I don't remember how
backwards.
to factor.
What goes here?
-1.
Minus 2 and positive 1, right?
What's the easiest way to
Yeah, what was it? It was like.
What's the easiest way to factor? I don't know.
I don't remember
Can
anything.
we bring that one here for like 5 minutes?
What? Can I teach factoring? No.
No, Mr. Paddock looks like.
Uh,
Yeah,
If
let's
you-
have a guess.
if you don't factor it correctly, it's called factor fiction. Yes. Factor fiction. Okay, but the way I've taught factoring, if I know that I needed to multiply to -3 and add to -1, to those of you who took algebra, I make a little tree like this.
Wait, -3.
I want it to multiply, -2, sorry. And so I say, what two numbers multiply to -2 and add to -1? And those are -2 and +1. And those are my those parts. That's how I teach it.
Wait, it's what adds up to 2?
Adds up to the middle, right? So in this case, -1, and multiplies to -2. But this is not algebra class. And there's, when you have non-zero or non-1 coefficients of this term, there's the cross and box method, but I'm not, or the Indian method Mrs. Voss teaches, but I'm not going to go there because I don't want to. Okay. Girls, shot your big ones. I still have 2 more that I'm going to do with you. And then I'm going to give you some time to start on your homework. Okay? Simplify. Simplify. Sine of t, sine of t plus cotangent of t. I guess it should make my t's look the same. Times cosine of t. Okay. Anyone see something I could do here if they say simplify?
Factor it out.
Oh, because cotangent is.
Okay, study. Focus. I know it's Friday. So there's nothing I can factor out because there is no common factor here, right? What can I do? Yes. You better watch this one. This one's a little tricky. I'm going to change cotangent into not 1 over tangent, cosine over sine. How do I know to do that? Because I see a cosine up here, and I see a sine over here, and I kind of, if I have sines and cosines, usually you can simplify things pretty good. Okay? Now, I want to have a common, this is, I can still simplify this. Who wants to guess what to do next? Yeah, cosine squared, you can do something. Sam, can you tell me what to do back there?
Cosine squared?
Yeah, you can do cosine squared, but there's more to it than that.
Cosine squared over sine.
Can you just use the cosine switch?
Can't you just do this? Boom, boom?
No.
No, because it's over addition, right? I can only cancel things if everything's being multiplied. Okay, here's what you can do. You can multiply it, not by cosine. You can multiply this by sine of t over sine of t. Why would I want to do that? What's sine of t times sine of t? Sine squared of t. And that's over sine of t, right? Because I have to multiply the top and the bottom. And this is equal to cosine squared of t over sine of t. Now, this is a common denominator, so I can write this as sine squared t plus cosine squared t over sine of t, right? What's this equal to on the top?
1.
1 over sine of t, and it's always better to not have a fraction than to have a fraction. How can I write that without a fraction? Cosecant t. Okay?
Wait, what'd you do with the cosine?
What I do with this here?
No.
Here?
In the
This?
green, where'd you do that?
Because cosine times cosine gives me cosine squared.
Oh, so you just multiply.
Yeah, and because I want to do that, because I know that once I write this over a common denominator, I can change that into a 1, and I get that. Pretty good, huh? Isn't that fun? No. Yes, Jacob? How did I get sine squared? I multiplied sine of t by 1, but I called 1, like this is 1, right? But I want to find a common denominator. So I multiplied by sine over sine. And I also kind of knew that if I multiply this, then I'll have a sine squared and a cosine squared, which turns into 1, which is nice. So you have to practice these. You practice them, you'll get better at it. Okay? Next type of problem that you're going to see, this is the last one I'm going to do for you. What? Quit talking about non-math related issues. Okay? All right. It's not math related. I'm not done yet. So, what if they say 1 over 1 plus sine x? This one is probably not so obvious. And they say rewrite without fractions. Rewrite with no fractions. Could you do this? No.
Technically.
Let's see what you do. Right here, right now.
Wait, yes.
Okay. How? Oh yeah, I guess you could.
Yeah, that's easy.
No, it's not that easy.
But isn't it?
You cannot do this.
Oh,
You cannot do this. Okay, that's math. No. That's against the rules. Because that's like saying 1 over 1 plus 5 equals 1 plus 1/5. Okay? Right? Which it's not, is it? It's 1. No, it's not. Okay. That's 1/6 and that's 6/5. How about if I tell you what to do? Okay?
That sounds good.
yeah.
It's good that you're making guesses though. Okay? So what you should do is multiply it by what's called the conjugate. Okay? I'm gonna put it differently. The conjugate is like this: 1 minus sine x. And whenever you want to get rid of fractions in the denominator, it's useful to multiply by what's called the conjugate. Conjugate? Because what happens then? I'm going to, on the top, I'll have 1 minus sine of x. What will I have on the bottom? What's this multiplied to? This times this.
Sine squared x.
1 minus sine squared of x. Right? This is like going 1 plus x times 1 minus x, right? The middle term disappears, so you get 1 minus sine squared of x. How can I rewrite 1 minus sine squared of x? Cosine squared of x. So I get 1 minus sine of x over cosine squared of x. And see how I said you couldn't write this as 1 over 1 plus 1 over sine? What you can do is write this as 1 over cosine squared x minus sine of x over cosine squared x. You can break apart that fraction. Why would I want to do that? Because you want to get rid of fractions. What's this equal to? Secant squared of x. What's this equal to? So this is the same. I'm going to do a little. This is sine of x times over cosine x times cosine x, right? What's sine of x over cosine x equal to? This part is tangent of x, and this part is secant of x. So I could write this as tan of x secant x. Okay? That's as good as it gets. Okay? So that's how you read. That's a long. So first I multiply by the conjugate. Then I use this identity to change this into cosine squared. Then I broke apart my fraction. Then I did this. And then it gets even better. It only gets better if you get rid of this. Oh! Okay, no, I'm just kidding. Okay. Wait. No, you got that one. Anyway. You can figure it out. Okay.
No, he like
Are you
erases
recording
the
this
C.
right now?
Yeah.
It gets better like
Okay. Thank you. Your homework is this. I am going to, you guys, chill up. I'm going to do number 79 with you because it's a lot of work, but also 79, 83, and 88 are called trig substitution problems. And I want to show you how to do those because I didn't really show you, and there's 3 of them, and I think they're good practice, and they're good for when you get to calculus. So I have to look it up, and it's on page 354. And this, I'm going to just do one of your homeworks for you, and then if you have other ones, you could ask. Okay. So 354 is called trig substitution, and you do this when you're doing integrals in calculus, which some of you will go, oh, I remember this from Mr. Leader's class. And it will say rewrite substitutes, use trig substitution to find an algebraic expression as a function of theta. Okay, to find the expression as a function of theta. Let me just show you what they do. They give you this 25 minus x squared. This is number 79 on your homework. Number 79. And then they say that x equals 5 sine of theta. This is the trig substitution you want to do. Because in calculus, you'll be asked to take the integral of things. Okay? And the integral of square root of 25 minus x squared is almost impossible to do with rules of calculus. But the integral of something involving a trig function is easy to do with calculus, okay? And because you just memorize rules and stuff like that. So what you do is you take this they tell you what to substitute in calculus you'll have to figure out what to substitute, and you put it in where you see an x, okay? So, so I'm going to take the square root of 25 minus, I'm going to plug the whole thing in and square it, okay? Minus 5 sine theta squared, okay? And then you square this stuff inside of the parentheses. What does that become? What's 5 squared? 25 sine squared theta. And you can't just take the square root of this and the square root of this. What you need to do is first you need to factor out what from both of these? 25 times what? 1 minus sine squared theta, right? Because there's 25 times what will give you this? Right? What's 1 minus sine squared theta equal to? That's equal to 25 times cosine squared theta. What's the square root of 25?
5.
What's the square root of cosine squared?
Cosine.
Cosine theta. So that's equal to 5 cosine theta. And you would have a plus half and a minus half. On these problems, they ask you to look for your answer in the first quadrant. So you would just take the positive answer, okay? And that's called trig substitution. And that's kind of tricky stuff. But back then, so when you get to calculus, you'll do stuff like this. Find the integral of that. And that's very easy to do using rules of calculus. But it's impossible just about to do the integral of that using calculus. Okay? So, or using rules of calculus. So that's why you do that. When you get it. Okay, that's it. You saw your homework. And sorry I had to talk so long. But